Good morning. You're watching Solar Impulse Live TV. We are live here from this huge, booming hangar, Hangar 2, at Moffett Field in the Bay Area of San Francisco. Now, this is a Moffett airfield which has a very rich and exciting history, full of adventure and discovery, and we're hoping that Solar Impulse will add another chapter to this history. Now, before we get started, just a reminder that every leg of this mission across America will be broadcast live on solarimpulse.com. So make sure that you check in. A very good way I recommend to check in is to sign up for our supporter program. It's free to do so, and you'll get emails sent to you giving you all the information you need about Solar Impulse. And check in the website at any time. There's loads going on here, a huge amount of information. Now, the aim of today's conference is to give you all more information by letting you hear direct from the co-founders of Solar Impulse, André Borschberg and Bertrand Piccard, who are seated to my right. And Solar Impulse would also not be possible without the support, the huge support of our partners, and we have some representatives from our partners seated here as well, and each of them is going to give a short introduction to why they are involved in this project. Also, we have Columbia involved in this, Columbia, the university in New York, and you can perhaps see some of them behind me. You will in just a second. Give us a wave if we can see you. They're all clapping now, and they're going to be asking questions. We also have some students from Stanford here with us, here at Moffett Field. Any people from Stanford here? Raise your hands. And we have engineering students, very intelligent people, so the panel will have to get ready for some pretty in-depth questions. I hope you're all prepared. Well, without further ado, I'd like to hand our microphone over to our co-founders, Bertrand Piccard and André Borschberg, just to give us a short introduction to Solar Impulse. Gentlemen.
So, good morning to the one who are on the West Coast, and good afternoon for the East Coast. It's true that for André and I, it's really nice to welcome you on this educational part of Solar Impulse, because Solar Impulse, of course, is a project of an airplane flying day and night with absolutely no fuel, just on solar power. So you will discover how huge it is, how light it is, how energy efficient it is. So in a sense, it's true that it's a way to promote clean technologies to reduce the impact of human being on nature, and at the same time create jobs in the clean tech industry and sustain growth for our world. But more than that, it's also a way to speak about pioneering spirit, about innovation. And it's so important in our world to see that if we want to solve the big challenges we have in front of us, we absolutely need new solutions, new way of thinking. As long as we will remain prisoners of old ways of thinking, of certitudes, of habits, of common assumptions, of convictions, we will never be able to make a better world. So pioneering spirit and innovation is not so much what we do, it's how we think. It's a state of mind. And we don't need new ideas for innovation. We much more need to get rid of old ideas. Innovation is not something more, it's sometimes something less. It means that when your head is free from the old ways of thinking, then there is space for new ways of doing. Then there is freedom, because freedom is not just doing everything we want. Freedom is about thinking how we could think in every possible way. That brings freedom. And I believe this is what we need. And that's why it's really important for us all to present the plane, but also to explain you why we're here and why we're also making educational programs.
Good morning, everyone. To be able to fly with a solar-powered airplane day and night, we obviously first integrated, as you certainly have understood, the newest and best technologies. But I think it really became possible when we started to understand that to fly day and night, we had to reduce the energy consumption of this airplane. And that's what we learned when we did the feasibility study, so that's already 10 years ago. We learned that it was not going to be just a project about building a new airplane, but really a project about saving energy. So all this notion of efficiency became the key word of our team, of all our partners. And when we talk about efficiency, of course we think about aerodynamic efficiency, and that's what explains why we have, in fact, this size behind us, and the wingspan of a 747. We get more lift and less drag, we get more benefit and less losses, if I can put it this way. And of course, when we have this wingspan, we have a large surface to integrate solar cells. And if we calculate how much energy we can collect over the entire day, and if we average this energy over 24 hours as we fly day and night, the power we have available is approximately the power of a scooter. So that was the starting point, and the airplane has to be huge. The power available was moderate, if not relatively small. And of course, if you know aerodynamics, physics, you can calculate how much weight you can afford. And the weight we had, the weight budget we had, was the weight of a small to mid-sized car. So that was the challenge when we started the project a few years ago. And interestingly, we went to present this project to a lot of airplane manufacturers, sailplane manufacturers, because they are used to build also lower or low-weight aircrafts. And very quickly, they came back with their answer. They thought it was impossible. So we were in some ways forced, but as we were convinced there was a solution, we decided to set up our own solution, our own team. And this team, in fact, started to think about how to design and how to build this airplane to achieve these goals. But we didn't have technologies. So we had to look for the best technologies available, what would be suitable. And today, in fact, this technologies has been brought by a very big family of partners. And these partners provided their know-how, their products, their solution, their research to bring this solution. And it's also interesting to look at the list of these 80 partners. Only one come from the aviation industry, and the 79 other come outside of the aviation industry. And so the solutions were not available in existing aircraft. We had to bring them from outside. And this is for materials. I will hear afterwards, I think, a little bit more in details. Of course, this is also for all the electric systems. But all these solutions made it feasible. But it's also interesting to see that the motivation of these partners is not just to build an airplane, because they are not in aviation, in the aviation world. So they were interested to understand maybe which kind of products will have to be developed in the future, which kind of application was required in the future, which kind of solutions could be set up, but used and usable for other applications. So everything we have in this airplane can be used on the ground. The solar cell can be put in your homes, the batteries can be used in your car, and the insulation materials in your fridge. So that's very interesting to see the amount of spin-off or virtual spin-off that we can develop.
Thank you very much, André. And we're going to hear a bit more about the partners now. We have, as I said earlier, some of the representatives here. We're going to start with Solvay. Solvay is an international chemical company and was the first partner to sign up for Solar Impulse. And we have two members of Solvay here, Claude Michel, who is head of the Solvay Solar Impulse Partnership, and Larry Hoff, who is a lab manager for corporate research to innovation at Solvay. And start with you, Claude. If you could give us a little bit of information about your involvement with Solar Impulse.
Good morning, everybody. Solvay is one amongst the non-aircraft partners. In fact, we are a chemical company born in Brussels, Belgium, 150 years ago. So this year, we are celebrating our 150th anniversary. We are still headquartered in Brussels, Belgium, but we have a strong European anchorage as a chemical company with a global coverage and absolutely global worldwide ambitions. When we first met Bertrand and André, it was back in 2003, we very quickly understood that between our company and this new project, we would find an absolute good fit. Where? First, in the values. If we are there for so long, it's just that because across ages, we have always been active and involved in innovation. And innovation is really one of our key drivers across time. Innovation and also pioneering spirit, as Bertrand just mentioned. Second point, when we met this team, we very quickly understood that it was not only a project for building a new plane, it was a project of new advanced materials. And we very quickly thought that to build this plane, to make it a success, we would need new solutions, new materials, new products, and here we are back to our core competencies. And in fact, we have been active in various domains, but the main ones are all the energy chain, from the energy capture to the storage, to the lubrication, and also to the lightweight. How to make this plane resistant and light.
And Larry, give us a bit more information about some of the future applications. Looking forward to the next airplane, SIB. We should point out this is a prototype airplane you can see behind me. The plane that's going to go around the world in 2015 is currently in construction. Larry.
Hello. So what I would like to talk about is what's going on in the future. So much like the Solar Impulse team, we're trying to push the horizons to the next new and great thing. So one example that I can give is in a solar cell, not to go through too many details, but you have a piece of glass, and behind that you have a conducting layer made out of a material called indium tenoxide. This material, unfortunately, is very brittle. It's also very expensive and in short supply. And it can't be put onto plastic. So because it takes 1 square meter to raise 8 kilograms off the ground, you can imagine that weight is a very, very important thing. So we're looking at new materials that can be put onto plastics that are flexible and that are inexpensive to really have the next generation of solar power. Now, if you're thinking this doesn't necessarily affect you, the same exact type of conductors are used for your cell phone. If you have a touchscreen on your cell phone, behind the glass is something called indium tenoxide. In the future, what we're hoping is that you'll be wearing your cell phone on your wrist or having printed electronics or all these new fun things that will go beyond what we have right now. And just as an anecdote, I was reading recently when the Montgolfier brothers invented the hot air balloon, someone asked Benjamin Franklin what use he saw in such frivolity. And he said, what use is there in a newborn baby? And that's kind of the feeling that we have about this project here. It's only just the beginning of magnificent things. Thank you.
Thank you very much, Larry. I want to move on now to our second representative of a partner company. It's Frank Resch from Schindler. Schindler is, of course, an elevator company. And you might be asking, what is an elevator company doing involved in an aviation project like this? Frank, maybe you can explain.
Yeah, good morning, everybody. Yeah. Good morning, everybody. Yeah, it's a good question. I would like to explain where is the connection between Solar Impulse and Schindler as an elevator and escalator company. And there is, I think, one main issue that you probably can also imagine, that we are transporting people. So we are transporting people like Solar Impulse is transporting people vertically, and we have a target to do this in a clean and a sustainable way. And this is where the connection comes and where we can, as partners, learn a lot about how to develop and how to implement the innovation coming out of Solar Impulse into our products, which are definitely having a commercial background rather than a pure technological and innovative background. And this is how we are got involved in the project and how we are still involved in the project by embedding engineers coming from a more civil engineering, mechanical, electrical engineering background, contributing to the project team, Solar Impulse. This is what we deliver, and what we get out of it is inspiration, is this pioneering spirit, is new technology and access to a network of engineers and experts that we can then transform into solutions that make us fit for the future, that provides clean technology for the next decades. And you have to imagine, Schindler is transporting people, about 1 million people a day, day by day. So that is also kind of a responsibility for our company to deliver something that is sustainable, that delivers for the future a cleaner environment, using less energy, and being much more efficient. So what are the learnings we made and what have we transformed already into solutions? First of all, the three main objectives of Solar Impulse are our objectives as well. Low weight, because the less weight the elevator has, the more people we can transport with the same amount of energy. The second one is optimizing our traffic management in order to utilize the elevator in a much better way. Solar Impulse is doing exactly this, optimizing their flight pattern in order to store energy during the day that they need during the night. So you have to have a smart way, not just a technical solution, but also a smart way to do this and the right algorithms. And the third one is you have to have efficient systems. This is what Andre said and where we are fully aligned with that. If the system is not optimized and not efficient, you cannot get independent of the grid. You cannot have the zero net emission, zero net energy approach that we are targeting for. And finally, just as a last word, what is the result out of that? This is a solar-powered elevator that we are bringing to the market now, which is in the same way as Solar Impulse, independent of the grid, and where you can run your elevator day and night, also just driven by the sunlight.
Okay, thank you very much. And finally, before we move on to questions and discussion, I want to introduce our last representative on the panel, Bruce Bender, Vice President of Market Development for Bayer Material Science, which is also a partner with Solar Impulse. Bruce.
Thank you, Connor. I really appreciate being here. I think most of you know who Bayer is. I'm happy to point out that our brand was recognized, again, as one of the top brands in the world. Many people recognize us for our pharmaceutical products, but Bayer is more than just healthcare. We're also a nutrition company and a material science company. So I'm here representing material science. I'm happy also to say that we're celebrating this year, by coincidence, our 150th anniversary. So between Bayer and Solvay, we have 300 years of chemical experience here. So congratulations to you, and I'm happy for our company. We're really pleased to be a part of this pioneering event or this project in aviation history. We've been a member of this team, supporter since 2010. Really is an opportunity for us to take our some of our key objectives of innovation and sustainability and put those into practice, working with fantastic partner companies and a really excellent team, the Solar Impulse team, to take our technologies further than we've had before. We have a mission statement which is science for a better life. Science for a better life. So if you think about that mission statement, it's exemplified by this this project here. Really developing something like this that is not just clean energy, but it's absolute clean energy. There's no fossil fuel associated with this this airplane, and it presents material challenges which then a company like ours can take our expertise and really apply to this airplane. Let me talk a little bit about my background. I'm born and raised in Detroit, Michigan, and I come from the automotive industry. My father was with General Motors for more than 30 years. His father before him was in automotive, and I've always been fascinated by technology, and I'm really proud to work for a company with such a rich history of innovation. I'll give you a couple of examples. In our Leverkusen, Germany laboratories in 1937, Dr. Otto Bayer, not related to the company by the way, he discovered the polyurethane reaction. That discovery was so significant in our company's history that the highest technical award that we give every year is called the Otto Bayer Medallion. It's absolutely a fantastic discovery. Now, in 1954, in our laboratories also in Germany, Dr. Hermann Schnell discovered the polycarbonate reaction. The reason I mention these things is because I'm proud to work for this company. It's got that rich history. But these technologies are apparent on the plane that you see behind us. I could be a little bit like a flight attendant. At the ends of the wings, you see polyurethane at the end of the wings, polyurethane for the engine housing, polyurethane which is also used in the cabin. So these are rigid polyurethanes. The chemistry is very versatile, so there's also polyurethane foam, which is really important to keep the pilots comfortable because they're dealing with nighttime temperatures which can drop well below minus 40 degrees and daytime temperatures which can increase above 120 degrees Fahrenheit. And so managing that is critical there. Switch. Also, other technologies that we have on the airplane is you see the windshield behind me over here. That is polycarbonate film. So I talked about that discovery. So polycarbonate film, two films separated by a layer of air, designed very specifically for this plane. We also have polyurethane technology which goes into it, high performance adhesives and coatings that are found throughout the plane. Now all of these things can be translated to everyday applications, whether it's in the construction industry where polyurethane foam is used, insulation, or polycarbonate for automotive to replace glass, or polyurethane structures to provide lightweight materials for automotive. So these inventions then are things that we can take to everyday applications. In Leverkusen we have about 30 of our scientists who are devoted to this project. We have about 1,000 around the world that are contributing in one way, shape, or form. And we also are working on the development of new technologies for the plane, which will go around the world in 2015. We're very proud to be part of this, and I hope you'll join me in celebrating this historic flight across America, following it in the media and the social media. And with that, I'd say thank you very much for having us as part of this project.
Thank you very much, Bruce. And of course, the easiest way to follow the whole project is via this website, solarimpulse.com. Every leg of Across America will be carried live. You can follow the whole thing, and you can find out also information about all these partners on that website, solarimpulse.com. Right, now is the chance for you to ask some questions, our invited audience here at Moffett Airfield on the West Coast. We also have Columbia students listening in, watching as well on the East Coast. Now, my understanding is that we have some of the most intelligent people in America at these universities, so no pressure, but there will be amongst us a competition to see who has the most intelligent questions. So let's set the bar pretty high. I'm just going to see if we can hear from Columbia now. Hello, Columbia.
Yes, we're here. Can you hear us?
Hello, David. Yes, we can hear you. David Valencourt.
Yes, terrific.
You have some of your students who are standing by. Do you have the first student ready, David?
Yes, I would like the first student like to come up and ask a question. I could tell you while they're coming up. Can I invite you up? Anyone who would like to ask a question? They're mulling it at the moment. These students are the students in the Art of Engineering. It's the first year course, Introduction to Engineering at Columbia. I am sure that some of them have something to ask.
This is a very rare chance that you have.
They're making their way to the front there. Okay. They are slowly making their way here.
Hello. My question was, since you're flying for so long, how do you go about living in the plane for so many hours?
Did you hear that question? Yeah. A little bit louder, please, just so we can hear your question. Yeah.
Since you're flying for so long, how do you go about living in the plane for so many hours? Like, how do you go to the bathroom and eat and things like that?
Well, I think the first answer was to say that the driving force is passion. When Audrey and I are working on this project since 10 years, once we sit in the airplane, we're really happy to be there. And of course, we have no toilet. So the flights are limited to 24 hours or 26 hours. There's no autopilot, so we need to use some techniques. André is using yoga and meditation techniques. I'm using hypnosis techniques to be able to stay aware and focused on what we're doing. And the feeling of flying the most incredible machine that exists today, I think, is a huge stimulation to survive. And some say the cockpit is so small, how do you manage to stay there? Well, when you know that outside it's minus 40 Celsius, you're happy to be inside, even if it's small.
And how many times have you been asked the bodily functions question? 1,026, I think, now? Something like that?
About the bottle? Well, you know, you take up basically, well, I'm a medical doctor. You're engineers. I hope you will cope with my answers. We take off with full bottles of water on the right side and empty bottles on the left side. And when we land, it's the other way around.
Now, does anyone here on the West Coast have perhaps a more elevated, high-minded question that they would like to ask the pilots or any of our partners? We have a microphone being passed around now. Yes, sir.
Yes, question for 5-10 years ago, you probably had, these are the problems we're going to face. Which of those problems ended up being more complicated than you thought or easier than you thought? I don't know, the structures ended up being a non-issue, or on the contrary, you know, what has changed your goals throughout this whole project?
I think the first things we did, and the feasibility that was conducted with the Swiss Federal Institute of Technology, which is, I don't want to say the MIT of Switzerland, but I'm sure there is good examples here on the West Coast as well. But it's one of the good engineering schools we have in Switzerland. And what we did was to try to understand how technology could develop over 5 years. In fact, I think we spent quite a lot of time, because when you do the design of the airplane, and if you think about, and if you use what you have now, of course, it's going to be very different when you can do the integration 5 years later. And so that's the kind of thoughts we did regarding the batteries, regarding the solar cells, and I guess a little bit also on materials. Also, this part maybe is less predictable. I think what was surprising, certainly, but I guess it's true for any project, is that you underestimate the complexity of what you are going for. And thanks God you do underestimate, because I think you would not start it if you would know everything and all the difficulties that you have and that you may face. But that's certainly true. And the second airplane is at least twice, if not 4 times more complex than this one. And that has been impressive. I think in terms of technologies, we are quite close to the objectives that we have set when we did this feasibility study. We may have been a little bit conservative, which I think is good. So the results we have, for example, in terms of energy capacity in the batteries is exceeding our goal. To give you one number, we were at 150 watt-hour per kilogram at the time. We set an objective of 200, 220. We have 240 now. We'll have 260 in the second airplane.
I'd just like to throw this over to the partners as well. Could you give us any examples of innovations that have come about since your association with this project?
Yeah, we can build on this example of the batteries, because this won't happen alone. You know, a battery is basically, you know, electrochemistry. And in fact, in our core business, we are electrochemists, so we understand and we master all these processes. And in fact, with the battery supplier at Solar Impulse, we have been improving their performance through, you know, all the components of the battery, whether it's the separators or the binders at the electrodes, or the component at the electrodes and the electrolyte itself. All these are new molecules or macromolecules we developed for Solar Impulse, but also for our own business in the batteries you have in your iPod, iPad, and all mobile devices. So, and it will never be finished. You know, it's a continuous improvement, and maybe much more than incremental improvements, we will see real jumps, you know, in the performance of these batteries.
Yeah, I would like to add a different subject. I talked about the polyurethane chemistry, and I talked about the insulating foam. A key challenge on this project was to get the foam and the structure to be as light as possible, yet have great insulative properties. And that is a real challenge. And the insulating properties is a function of your porosity, let's say, of the size of the bubbles inside the foam. And so this project, one of the innovations that came out of this was a so-called microcell technology. So we were able to make those pockets very, very, very small, so we can use thinner polyurethane insulation and still get the insulative properties that I mentioned are so important in the canopy.
Well, I think we've got time for another question. Let's just head back to Columbia now. And David Valancourt, any of your students lined up for another question?
What kinds of software did you use to simulate and create the airplane, and how accurate were they when you ran the simulation?
I mean, software is quite simple. It's a MATLAB platform. He's here, that's right, yes.
I can see you.
But I was happy to look at him as well. But that's a simulation tool that we started to develop right during the feasibility study, and which is still in development, because you can improve all the time. So each solar cell is identified separately. So we know, for example, on May 1st, if we would be over Nairobi at 10 o'clock in the morning, which kind of sun rays we would get. And so all the airplane is totally simulated in full detail. So what we did with this, first, is to compare different design solutions. And that's how we reached this airplane that you see behind me, or behind us. So we really worked out what we thought is optimum, and it's an optimum between day and night, because we have a cycle during the day where we collect energy, and of course we have a cycle during night, which is totally different. It's when we use this energy. The second use of this simulation tool is to make this airplane fly, and it's flying now over the Pacific. The second airplane is flying now over the Pacific in a virtual way with a real meteorology, so we can see if our people on the control center are able to predict the weather in such a way that we can steer this airplane in good weather conditions and make it reach its destination. So that's a simulation tool we use in 6 years, every year, to check and train, in fact, the team on the ground to see if we can achieve this flight around the world.
I think the question was also about the construction and the design of the airplane. And for this, we use the CATIA design software from Dassault System.
Thank you very much, Columbia. The questions are getting much, much better. If you could just sit down after you've asked the question, Columbia, because you're all about 6'6". I think it's the whole basketball team of Columbia who are in asking the questions today. Now, we've got loads of questions here on the West Coast. This gentleman had his hand up for quite some time with the Superman T-shirt.
Appropriate. Congratulations on a safe journey. But what came to mind was, I assume you didn't have parachutes or an ejector seat, but was there a bailout plan that you considered if some malfunction or some, catastrophe were to happen?
Well, the first thing for us, of course, is to guarantee the safety of all the people on the ground. So in case anything could happen potentially to people on the ground, we would go on an empty area and bail out. Now, of course, you think twice before you bail out, because it's a so extraordinary airplane with so much redundance that there is a lot of good systems that will probably help us to come and land whatever the problem will be. And we can land also with no engines. We have a glide ratio, which is about 37, a sink rate that keeps us in the air for a long time. If you have complete engine failure at 27,000 feet, it takes 5 hours anyway to come and land. So you can find an alternate airport. So we're quite confident that the engineers made a really good work in the conception of this airplane. So we will hopefully not need to bail out. But in case, we have a parachute.
Yes, so reliability is a critical point. And so we did two things to achieve that. The first one is that everything is measured on this airplane. We have sensors all over, accelerometers, sensors, and all the information about the electric systems is downloaded to the ground by telemetry when we are close by satellites when we are far away. And so the engineers can follow what's going on, and every specialist can advise the pilot in case there is something which has to be taken into account. And the second, I think, step we did was really to do a step-by-step approach. I mean, when we did the first test flight, or the first flight of this airplane, as we had no experience with such an airplane. This size, this weight, this speed, there is no airplane in the world which has been flown like that. So we didn't know it would fly, we didn't know we could control it. So the first flight was 0.5 meter about the runway, 1 kilometer distance, and about 0.5 minute duration. So very short, but extremely helpful because we could measure everything, understand that it was close to what we expected, and then do the next flight. So by doing this step-by-step approach, in fact, you reduce the risk.
And also during this month that we've been here on the West Coast, there have been more test flights with a test pilot.
Yes, well, I mean, the airplane has been disassembled in Switzerland, was shipped here in a 747. And it barely could fit the space we have available, but it did. And the 747 nose, in fact, just entered here. It was disembarked and reassembled in this hangar. And of course, after such a transport and the assembly, disassembly, we needed to test if everything was fine. And we did this last test flight this morning over the bay. I don't know if you saw us coming back, but the airplane took off around 5, came back around 7, and it worked perfectly well. We are very happy, I tell you.
And a bit tired. Some people got up very, very early this morning, but it was all worth it.
Well, it's part of our schedule, so...
Okay, let's head over to the East Coast of New York, to the engineering students at Columbia. Do we have another question from Columbia? Yes, we do. Another very, very... He's a bit taller. He's really 7 foot, this guy. Okay, what's your question?
Yeah, they breed them here. My question was about, you mentioned it was going to be as heavy as a light car. That's around maybe 1,000 to 1,500 kilograms. How do you plan to keep it stable when you're flying in the range of polar jets or maybe even tropical jets? Tropical jet streams up in the...
It's true that when I flew around the world in a balloon in 1999, I was looking for the jet streams, and the strongest was the better. And we're flying sometimes at 234 kilometers per hour, so it's about 165 miles per hour. This is what you look for. Now with solar impulse, you don't really look for that. With solar impulse, you need calm weather, because of course the turbulence can destabilize the plane. You have such a small and light wing loading that you need to fly in calm air and not too much turbulence. So the importance of the weatherman is tremendous. They also calculate where we have the favorable winds, no turbulence, and sometimes there are strange things happening. You know, when the speed of the wind, of the headwind, is stronger than the speed of your own plane, you go backward. And we flew backward with this airplane several times. So it's quite strange. In this case, you just have to change your altitude to find a better wind, and that's it. So it's true that the relation with the weather is not as with a fighter jet.
Do you have a follow-up question to that? Right. You said you have the wingspan of a 747, and I'm guessing a fraction of the weight of a 747. Could you talk about any of the mechanical safety mechanisms you have to protect you against, like, say, like yawing or just like wrong gyration?
Repeat the question. It was about safety considerations. Is that correct?
Along those lines, yeah. But more along, you have the wingspan of a 747, but around a fraction of the weight. How do you plan to like take care of any like unforeseen incidents up there?
I think it's interesting to see a little bit the differences of this airplane versus, like you say, 747 or another airplane. I mean, one difference is because of its low speed, when we do a turn, the inclination we need to do a normal turn is about 2 degrees. With a transport airplane, you have an inclination when 747 does its turn of 25 degrees. So it's extremely small. And when we are in a hurry, we go up to 5 degrees, which is still not much and not easy to see. So to cope with this challenge, we had to develop new instruments. We had, for example, the information degree by degree about this inclination. And we also have, when we exceed 5 degrees, which is for this airplane quite an aggressive turn, we have vibration on our body. The right arm start to vibrate, or a device on the right arm start to vibrate, and we know we are too strong on the right and we have to compensate on the left, and vice versa on the left arm, which is extremely useful, of course, if you get tired, if you are not fully attentive, if you do something else. And when you fly 24 hours, of course, you have to do other tasks than just holding the stick to control the airplane. So these are steps we have taken, in fact, to reduce the risk based on the particular behavior of this airplane.
Thank you very much. Okay, let's throw the open to the floor again here on the West Coast in the Bay Area. Let's go to this gentleman here, please, on the second row.
Good morning. Can you tell us a little bit more about the changes to the next generation plane that are coming up relative? You've probably learned a lot from this, and you've had a few years, some of the new technologies coming in.
This airplane is a test airplane. That's a flying laboratory. Was designed to demonstrate we can fly day and night. In fact, the first objective we had, really the first objective, that the airplane flies at least 1 minute, so that we can learn enough to understand in which kind of domain we are. And the second objective we had was to fly more than 24 hours, demonstrate we can fly day and night, which it did. But it's not an airplane for ocean crossing. We limit the flight to 24 hours. There is no autopilot. There is a very, very narrow cockpit. You can sit only. You can stretch your leg if you find the right hole between the pedals. But that's all. So the second airplane will integrate, of course, all the new technologies that all these guys have been developing in the meantime. So these are better batteries, these are better solar cells, we have some new materials, we have improved production processes. To give you an example, the structure of this airplane, what's inside, what you don't see, is the skeleton of the airplane. That's built out of carbon fibers. And the carbon fibers are built using carbon layers, where you have fibers on one direction, and you pile up these layers. And the thinnest layer we use today is a layer of 25 grams per square meter. You are not used to this gram per square meter, but in comparison, for example, a sheet of paper that you take out of your printer at home or in the office weighs 80 grams per square meter, so it's 3 to 4 times lighter. So these are technologies that we have been using. But above all, it's going to be fully reliable, or it has to be fully reliable because it flies over the ocean. 5 days, 5 nights. And also, instead of having a bad economy seat, we wanted to have a good business class, at least a good business class, maybe a first class kind of sitting.
Now, I know that all the partners have really had to innovate in order to help you both in this project. Going on to SEB, the plane which will actually be going around the world in 2015, could any of the partners give us some information about some of the extra innovation you've had to put into place, having learned from the prototype aeroplane?
Yeah, of course. And I'll give just an example. Putting the photovoltaic system on the wing is quite a challenge because the photovoltaic cells are very brittle, and we have to put them, you know, on a structure which will withstand deformations. So the way to go from a very brittle system to something which resists deformation is to encapsulate them. And the way we did it for the first plane is to encapsulate with plastic films. And we developed a polymer based on fluorine, which is transformed into a very thin film, 17 microns, 17 microns thick, so very, very light, which makes the job on this plane. For the second plane, we wanted to be waterproof. So we tried several solutions to make it really moisture tight, coating, spraying, or whatever. And finally, the best solution we could find was to put another layer of this film on the back of the PV system. So for the second plane, you know, on the top of the photovoltaic system and on the back of this system as well, we'll have a double layer of this fluorinated polymer.
And it's waterproof, not because we're afraid of ditching, it's because we like to fly in clouds. Huh?
I think we're ready for another question now from Colombia, first of all, and then we'll head back to the audience in front of us here. Colombia.
Hi, I had a question with the wind spar problem that you had earlier in your design process. I realized that it put your project deployment date like back for a year. And my question was, were you able to predict the breakage during testing of this wind spar? Was it caused by like the interest of lightening the load of the plane? And my follow-up question to that is, what was the process that you used to solve that problem? Was it drafting, computer-aided design? How did you do it?
It was a very difficult moment. As you said, we were delayed 1 year. So the breaking of the spar was certainly a shock for the entire team, because for the first airplane, we developed quite a great confidence about using the simulation tools, the calculation methods, and the software that we have. And I think for the second spar, we pushed the limit too far. On this airplane, the spar is the main beam which is in the wing. That's the backbone of the airplane. That's the part which takes all the loads. I mean, if the airplane flies in turbulence. And this spar is tested using the maximum load it could receive, and that's about 6 or 7 tons here, so that's something like 40,000 pounds of weight which you apply on this spar, which weighs about 500 pounds. We wanted to save more weight for the second airplane, so we changed production processes, we improved the materials, and we changed the design. And I think the design change that we made was too aggressive, which led, in fact, to this rupture, very close to the limit, but still below the limit. So instead of being just above or behind this limit, we were on the wrong side. And it's interesting to ask ourselves why, in fact. And I think in this project, you have a good mix between conservatism and risk-taking. Depending on the mix in the team, sometimes you are too conservative, and when you are too conservative, you end up by being too heavy or too complex or too redundant, and you have to rethink, in fact, your design. Or, on the other side, you take too much risk, and I think in this case we did, and that's what led to the failure. But we understood it, and now with the new design, we are currently doing the fabrication of a second part, and hopefully in summer, but with the tests we did and the analysis we did, we feel quite confident we're on the right track.
Okay, thank you very much, and best of luck to you.
Thank you. I think it's really important to address this type of issue about failures and risk of failing, because this is probably what holds back a lot of people from innovation. The people who want absolute safety to never fail, finally they never invent anything. So the risk of failing goes with innovation and pioneering. And sometimes you have to face people who will laugh because you fail. And you know who laughs when you fail? It's only the people who never dare to try. So finally, the most ridiculous people are the ones who make fun of the pioneers who have a problem. And in terms of failing, if you stop at the moment you fail, it's a definitive failure. But if you continue to try, it's only an intermediate step to success. And success will come if you try one more time than the number of failures. So don't be afraid of failing. Just be afraid not to try. This is important. And then when we have a setback like we had, do something out of it. Of course, the engineering team learned something, but you know, we were dreaming with André of flying to the US with Solar Impulse. And we just couldn't find a slot in our program to bring the plane here, to bring the team here, and to take the 3 months needed to cross America. And thanks to this delay of 1 year, we managed to find the exact perfect slot, and this is how we could come here. So at the end, very often you find the opportunities into the crisis that makes it extremely useful. And always remember the Chinese sign. The Chinese sign, crisis, is made out of 2 ideograms. One means danger, the other one says opportunity, a chance to take. So try to see always the opportunity rather than the danger.
I think we have time for one more question from the audience here. Bertrand's pointing out, so we have a young enthusiast here in the pink sweatshirt who'd like to ask, if you could stand up please, we have a microphone coming to you now.
What makes this airplane so unique and different other than it runs on solar panels?
So what makes this airplane unique apart from the solar panels and the wings? Who'd like to answer that?
There were already airplanes flying on solar power 30 years ago. It's a famous pioneer called Paul McCready who invented the first solar airplane. But the technology in those days just allowed the plane to fly in the middle of the day at noon, or between 11 and 3 in the afternoon when you have full sunshine, and there were no possibilities to put batteries to save energy. So at the end, what is very special with Solar Impulse is that in the last 30 years, technology has evolved, and with the pioneering spirit of today, we can have an airplane that flies almost perpetually. It means you load the batteries during the day with the sun during your flight to have enough electricity in the batteries, so you spend the night in the air, you reach the next sunrise, and then you capture the next solar energy you can find, and you continue the flight. So theoretically, this plane can stay forever in the air. Of course, the pilot not yet. When the pilot is too old, we have to land and change the pilot. But it will be, on the second airplane, possibility to spend 5 to 6 days with just one pilot up there. So you see, this makes it very special. And the symbol that we want to carry is also very important. It's not because you use solar energy that you are limited in what you want to do. And it's really an advocate project for clean technologies that can reduce the impact of human being on the environment and at the same time have a beautiful technological development, industrial development, creation of jobs, but in a much, much cleaner way. We have to be the clean generation from now on, instead of having been the one who were polluting so much the planet in the last 100 years.
Well, that's clearly your message for this project. As you've said many times, it's not just an aviation project, it's a project to carry a message, not to carry passengers. And as we can see from all the partners here, not one of them from an aviation background with an aviation company. And I'd just like to close up now by asking the partners as well, what is for you the legacy of the Solar Impulse project?
Well, I think that I might reiterate some of the things I said before, but for us, let me talk about it from a personal standpoint. When we started to get involved with this, it was in Europe, in Switzerland. I think that André and Bertrand went to our executive committee and, as Bertrand says, motivated them to become part of this project. And I'm sure among our tens of thousands of employees around the world is that many people were skeptical. This will not be a commercial venture. It's not, I think Bertrand had mentioned that in his lifetime, which is my lifetime, this probably won't be a commercial venture. However, the technologies that are being developed here are applied to the applications and the markets where all of us are involved, whether it's automotive for lightweighting, or whether it's construction or the electronics industry. And so the legacy for us is that all of the time, effort, energy, the collaboration that went into this project will result in improvements that will make our lives better. Again, science for a better life.
Yeah, I think for us it is the future. And I think this is the avenue which is shown now by Solar Impulse. In what direction does the industry have to evolve and to develop? And our industry in particular, because as I said, transportation is our main purpose, and only with the innovation we are getting out of projects like that, and the spirit, the pioneering spirit, we can make the difference then in the future, 50 years from now and even beyond that point. So translating this technology which we are getting out of this Solar Impulse into commercially available solutions, this is what we are taking with us, and this is why we are proud partners of Solar Impulse and supporting this project wherever we can.
Yeah, from our side, it's about the same story. I would say the benefits we can see directly from being a partner since 2004 are threefold. First point is about the business, because we are an industrial company, and in fact we design and sell products. This project is in fact a kind of springboard for triggering new developments, new products, new solutions for the future. And most of the products, of the Solvay products on board the Solar Impulse plane are already on the market. Second point, it's a question of image. You know, the chemical company, it's somewhat a difficult industry, and it's for us a way to make people understand that without chemistry you would never have, you know, your cars, you will never have commercial airplanes, you will never have your iPods, iPads and so on, you will never have food as we have today. So chemistry is everywhere, and this is a very good carrier of image. And third point, it's for our people. I'm very, very happy to say that the human aspect of the project for us as a company is key. You know, you cannot imagine the pride our people to be part of a company, you know, really involved in the future, you know, committed to finding new solutions for the planet.
Thank you very much. And we're nearly at the end of this first Solar Impulse TV show for 2013. Just want to get some closing comments from our pilots.
Probably you noticed as engineers how important for our future it is to study in your branch. And we have a lack of engineers in the future, because a lot of people want to study finance, banking, go into money business, and the future needs engineers. If we want to make a safer future in terms of energy, in terms of sustainability, in terms of saving natural resources, the solutions now come from technology. And the guy who makes the technology is the engineer. So it's very important for you to be motivated and also to be proud of the profession you have chosen, and to be proud to show what you can do, proud to show what you learn, proud to show the result for the world. So congratulations to our friends in Colombia, congratulations to you all here. It's a very, very important profession for the future, and we're very happy to be able, with André, to involve you around the Solar Impulse project, because maybe it's also motivation for you to see what engineers can do.
If I would have one recommendation to make, is I would summarize it by be guided by your passion. I think what drives our project is really our passion, and it's the passion of everyone, not just the two of us, but really I think everyone in the team, in the core team of Solar Impulse, but also with all our partners. Now that's a family of really passionate people. And when you are passionate, a problem becomes a challenge, and it's not a problem anymore. And the challenge, as we have heard, also becomes an opportunity. So the life changes completely. So I wish you good luck.
Well, thank you very much to our panel. Bertrand Piccard, who is the initiator of Solar Impulse, André Borschberg, the CEO of Solar Impulse, both of them the pilots of the plane you can see right behind us, Claude Michel and Larry Hoff from Solvay, Frank Resch from Schindler, and Bruce Bender from Bayer, all partners of Solar Impulse. Now, don't forget that you can follow Across America 2013 by simply signing up to our supporters program. It is free. You just leave your email address and we'll send you emails throughout the mission. And of course, don't forget to check in solarimpulse.com every time there is a flight, and the flights will begin in May. We can't give you any more indication exactly when, but from the 1st of May onwards, keep checking regularly solarimpulse.com for the rest of Across America 2013. And thank you to all of our audience here in Hangar 2 at Moffett Field in the Bay Area of California. And thank you also to you in Columbia at the mechanical engineering course in New York. And thanks to all of you watching on solarimpulse.com.
Thank you very much. Thank you very much for bringing your inspirational message to us and to the world. The best of luck to you.
Thank you.